Alright. We can also look at certain shapes and see that there might not be any vertices. So like for a circle, there's no points that connect two lines together. So some shapes don't have any vertices at all. Or some shapes, like you said, like a heart, can have multiple lines, but they only have two vertices, where both points meet. Next, how we can determine if a shape is two or three-dimensional is by the number of edges. So I'll draw the triangle again, and what an edge is a line connecting two other lines. So in the triangle, you can see that we have an edge right here, and right here, because they're connecting two lines.
Like three sides.
Yeah, exactly. Or if we draw a square, we can see that there's four edges because all the lines are connected to each other. Now some shapes might not have any edges, like a circle, because no two lines are connecting each other, and it's just bent all the way around. Now this is the part that gets a little tricky, is determining how a shape could be two-dimensional or three-dimensional. Now, on a two-dimensional shape, you can tell that the number of edges and vertices are the same. You see that we have one edge, two edge, three edges, and we also have one vertex, two vertices, three vertices. It's a little different for a three-dimensional shape. As you can tell from a three-dimensional shape, or if you look at a cube itself, you can see that there's a lot more faces and it's just not a flat image. Now with vertices on a cube, you have to factor in every point where the cube touches. So if you look at a cube, you can see that there's 1, 2, 3, 4 just on the top, and then you have to factor in when you turn it, there's 5, 6, 7, 8 vertices. Also with a cube, there's more edges than there would be a square, because you have a line connecting right here, a line connecting right here, a line connecting right here, here, and all the way around the cube. So the number of edges in a cube is going to be different from the number of edges in a square because there's another dimension. Like a square is very flat, doesn't have any depth or height in it, whereas a square is just a flat surface where a cube is going to be standing up. That being said, you can see that for a circle and a sphere, they're the same because they don't have any edges or vertices, because they're round shapes which don't have any line or any straight edges that come together. So now that we learned a little bit about what vertices and edges are, we're going to practice together to determine how many edges and vertices are in a given shape, and determine whether it is a two-dimensional shape or a three-dimensional shape. Alright, so I'm going to be drawing an image, and you guys are going to be drawing the same image, and we're going to go through together, and we're going to determine how many vertices and edges are in each shape, and then we're going to decide if it's a two-dimensional shape or a three-dimensional shape. So if we can all draw a rectangle on our board, and the rectangle looks like this. Now, do you guys know where the vertices are in this picture?
On the four corners.
Yep. So let's circle all the corners and add them up. So we have 1, 2, 3, 4 vertices. And do you guys know how many edges we have? Or do you guys know how to determine the edges?
Sides.
The sides. So we have 1, 2, 3, 4 edges as well. Now, do you guys remember what I said about if the shape has the same number of edges as vertices?
Mm-mm.
Okay, so if we know that a shape has the same amount of edges and vertices, then it's going to be a two-dimensional shape. Because it has no height, so that it's a flat image. So the number of edges and vertices will always be the same on a two-dimensional shape. So let's erase our rectangle. And let's draw a rectangular cube.
How did I do that?
I will show you guys how to do that. So what you guys want to do is draw a rectangle, and then you should draw a rectangle in the middle of the other rectangle, kind of overlapping it. And then you want to connect each line where each rectangle lines up with each other. So we can connect the lines down here because these are together, these two are together, these two together, and these two together.
Okay.
Now, this is where it gets a little bit harder. Alright, so we can see that there's a vertex right here. Right here. How many vertices do you guys have?
8.
8 vertices?
Yeah.
Alright, so let's determine how many edges we have now. Do you guys know how many edges you guys got?
11. 1, 2, 3, 4. 5, 6, 7, 8, 11.
You got 11?
I got 12. I really did. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 11. I missed that one. 12. Okay.
Alright, we can tell from this shape that we have 8 vertices and 12 edges. Because we have a different amount of vertices and edges, we can tell that the shape is 3-dimensional than 2-dimensional because there's more because the number of vertices and edges are not equal. So do you guys have any questions about how to determine the amount of edges and vertices? Do you guys understand it? Alright, next I'm going to be handing out a worksheet. And it'll give you different shapes. And you're going to have to determine the number of edges and vertices on each shape. And each part of each question is worth 1 point, and each part you get right is half a point. And if you would like to circle or identify where exactly where you get the vertices and edges, you can do so.
I'm going to stop it and start a new one.
Okay.
That was